Welcome to lecture 8 of Python. In today's lecture, we'll be covering functions. So, before we move into today's lecture, we'll have a look at last week's homework. And throughout the lecture, if you guys have any doubts, feel free to ask them in questions, and I'll be answering them. Cool. So, let's have a look at last week's homework. So, if you look at this, is the first question of last week's homework. So you were asked to get a list of numbers from the user and sort it using both bubble and insertion sort. And you had to count the number of operations for each loop and display it. So basically the number of operations in short is the number of comparisons. So comparisons are basically checking whether a certain number is less than, greater than, less than, equal to, and so on. And plus you add it to the number of swapping. Swapping is when you swap the values of A and B to B and A, which means A takes the value of B and B takes the value of A. In such case, the values get swapped. So this is what you're supposed to do for last week's homework. So let's see how that would be implemented. So the first thing that you were asked to do was to get a list as an input from the user. So probably the first thing that you would do is say A is equal to list input enter a list of numbers, and the next thing that you're required to do is sort them using both bubble and insertion sort. So probably what we can do is to start with bubble sort. If you've learned the algorithm for bubble sort, it goes like this. So first thing, we loop through the length of the list. So we say for I in range length of A, this outer loop loops through the length of the list, and we have the inner loop which has a specific condition, which is basically length of A minus I minus 1. Right. So these are the inner and outer loops, and to sort them, we're just going to do if A of j happens to be greater than A of j plus 1, we're just going to swap them. So this is the swapping part. Cool. Okay, and maybe at the end we want to print it. So this is for the bubble sort, and we'll do the same thing for the insertion sort. Then let's see what the question asks us to do. So for I in range, insertion sort is a bit different. We start from 1, we do not start from 0. That's how the algorithm goes. And we have a key which is defaultly set to, let's say I have 2 different variables here, making it easier. Let me declare another list which is basically A. So I'm just duplicating the list of A in another variable B. So let me just do this. Cool. So B of I and j is equal to j minus 1. So these are all the list of statements that you need for an insertion sort algorithm to function. So, and this is where the comparison happens. And then we assign it to B of j plus 1, and we decrement j minus 1. And if this is not true, we just say B of j plus 1 is equal to key. Good. So that's it for the both the insertion sort and bubble sort. So let's try printing both. Let's try printing A, let's try printing B, just to see if both of them work. You can notice comparisons are, as I said, greater than, equal to, and so on. So we have a comparison here. This is for the bubble sort, and we have a comparison here which is for the insertion sort. So to calculate the number of comparisons that's done, all we need to do is just declare a few variables here. Let's have compare bubble for bubble sort. Let's have swap bubble, which is to compare the swappings in a bubble sort. Let's have compare insertion, just to count the number of comparisons in insertion sort, and swap insertion, which is number of swappings in insertion sort, and we equate it to 0. So to calculate the number of comparisons, we would probably increment it here but the sum, if we increment it here, there's one mistake that we would probably be making. So we compare once here, so for each time in the loop we compare, but if we increment it here, there's one issue which is so, because only if this is true this will get incremented. If this is false, it won't get incremented. But for us it doesn't matter whether this condition is true or false. Every time it checks, we want to increment the compare. So this is not the right place to put it. So where we would probably put it is here. So we would increment compare bubble here. Cool. That's it for the comparison bubble part. So, and the second thing that we need to calculate is the number of swappings. So this is the swapping statement here. So if this is true, it enters this code, this block of code here. So what we can do is we can just implement the swap bubble variable here. So because swapping happens here, so each time this gets swapped, we increment the swapping bubble by 1. That's for the bubble sort. So we do the same thing here for the insertion sort. So we compare, and this is the comparison here. So for every time this compares, what we do is we increment compare insertion by 1. And the swapping also, you could say, happens here, because this gets assigned here and after that it would probably get swapped here. So we assign the swap bubble here. But there's one interesting thing about the insertion sort, which is if this is false, this is not going to run. So if this is false, the whole block of code is not going to run, and this code under here is going to run. But as you know that this is counted as a comparison, even though it's false, it's still counted as a comparison. So since that counts as a comparison and we can't increment it here, the next logical thing would be to increment the compare insertion here. And the other thing to note is if this is true, the swapping won't happen, but here sort of swapping happens. This is technically still called a swapping because half the variables already swapped here and we're just swapping it here. So all we need to do is we need to increment the swap bubble here as well. So we have a list and we have a few variables to check the number of comparison, swapping, and so on. So this is the bubble sort algorithm where we increment the compare bubble and the swap bubble to count the number of comparisons and swappings. And we do the same thing for insertion sort. So let's try printing the number of, so this would be for bubble sort. Say compare bubble and plus swap bubble, because the number of operations that, the formula for number of operations is the addition of compare bubble and swap bubble. So let's do the same thing for insertion sort here. So it would be compare insertion plus swap insertion. Cool. Probably modify this a bit. That should do it. Cool. As you can see, bubble sort takes more operations than insertion sort. You can try it out with different lists, but you can see that most of the time insertion sort is the most efficient sorting algorithm because it takes less comparisons and less swappings. That's how the algorithm is designed. So this is the homework given to you so that you guys can check the efficiency and prove it yourselves that insertion sort is way more efficient than bubble sort in most of the cases. Cool. And that's for the homework 1. So the homework 2 is a bit more complicated compared to homework 1. So let me just copy paste the homework here. Okay, so you were asked to get as an input a list containing tuples in the format name, category, and year of Nobel Prize winners. So it will be the category of the Nobel Prize they won and the year in which they won the Nobel Prize, and arrange them in alphabetical order of their last names using insertion sort, which means the last name would be the second part of the name. So we would be arranging them alphabetically based on their last names. So it will be Suzuki, Hanke, Roosevelt, Einstein, and Fochgart. So let's see how we can do that. So we've asked to use an insertion sort, so that's made clear. So we don't have to worry about whether to use a bubble sort and insertion sort, so that's made clear. So the first thing we'll do is, since I don't want to waste time getting as an input, I'll just hard code a list here. I'm just copying the same list and just pasting it here. Okay, so let's type the usual algorithm for an insertion sort. So we loop from 1 to the length of the list, and okay, so this is where we need to make some modifications to the algorithm. So we only need to compare the last name part of the whole list. So in case I say a of 1 or a of 0, what would that refer to? A of 0 would probably refer to this whole tuple here, which is not necessary. We only want this part of the whole tuple. So we would say a of 0 of 0, and that would give us the whole name of Akira Suzuki, which is still not necessary because we only want the Suzuki part of the whole name, which is the last name. So a logical thing to do to get the last name would be, I'll just split this. So to make it clear, a of 0 refers to Akira Suzuki in this case. So that's done. So now once it's split, what we would probably do is we can just once it's split, what we need to do is we just need to check a of -1 is greater than or equal to so and so. So basically what happens is when Akira Suzuki gets split, a basically will look like this. This would be a once we split it. So to access the end or the last name of the list, all we need to do is use negative indexing of -1. So a negative indexing of -1 would probably refer to the last name, and all we need to do is check whether this last name and this last name is greater than or equal to each other and swap them. As simple as that is. So I showed you an example of how we would do it for this tuple here. So let's just generalize it. So instead of using a of 0, we just generalize it to say a of I, since I starts from 1 and we move on. So then what we would do is, as usual, we just go through the algorithm of insertion sort. No big change in that. And here's where another change happens. So since we have to compare it with something else, we have to compare this last name with probably this last name. So we need to compare I with J. So we'll do the same thing here. We're just using J instead of I, and we're just calculating we're just getting of the last name of the J index, and the same code goes again. Okay, so this is where we would check two numbers. So in this case, you can see we check whether the key is less than B of J. But if you notice, we can't check that. We need to check this and this here, or to be more specific, C of -1, B of -1. So to get the last name, we just do B of -1, which would refer to Han K in the first case, is less than C of -1. Or if you notice carefully, we're just making very small modifications so that it fits our case. So then it's the same thing. We're just going to swap it. No big change here. And we're just going to decrement J. So we have another issue. The point is we've hard-coded C here, but J's value changes here. So we need to change C's value also, because when this runs and it goes back to the loop, C's value is going to remain constant, but C's value has to change when J's value change. So we're just going to copy paste the same statement which is here, so that the C's value also gets changed each time J gets changed. And we have the usual else statement, which says A of J plus 1 is equal to Q. So let's now try printing A now, and let's see what happens. Cool, I don't know what is the error back there, but okay. So we have the list here. I'll just repeat what I said. We have the list here. So the first thing that we do is we implement most of the algorithm of an insertion sort. So the reason why we use A of 0 is we only need the first name part of it. So a of 1 would refer to this whole tuple here, and 0 would refer to the first name. So that's why you're using a of 0. And on splitting this, we would get a list which has Akira separately and Suzuki separately, where Suzuki is the last name. So to access the last name, we use a negative indexing of -1. So to check, and this does basically the alphabetical check here. So if it's lesser or greater, it swaps accordingly. So yeah, I don't know why it didn't work here. Okay. So that's it for last week's lecture. Let's move into functions. So it's a fun concept. So let's see how functions work. So to be short, a function is a named group of programming statements. So it's a named group of programming statements, and all these programming statements can later be invoked to run all commands under it. So this would be kind of an informal definition of functions. Let's see how that would work. So declaring a function, we would start with def. That's the command for declaring a function. Let's say I want a function called sum, which takes in two numbers a and b, and all it does is it prints a plus b, because the sum function does that. So to call this function, so this is the named group of programming statements, the name being sum, and this is the group programming statement. And I said it can be later be invoked to run all commands under it. So to invoke or to run the commands under this, I would call the name and pass in two values, let's say 3 and 4. And let's call it a few more times. Good. You can see that it works. So to be a bit more specific about the syntax of a function, so all you need to do to declare a function is use the keyword def, then type in your function name. Once you type your function name, you can have all your parameters here, like a, b, and so on, all values that you need to be inserted. So once you have that, you can type all your programming statements here. And once that is done, to call the function, you just need to call, just say function name, and if there is any parameters, you have to include the parameters inside it. That's the simple definition of a function and how to use the function. This is the syntax of a function. So let's try a few more functions. So let's say I want to make a function to take the cube of a number. I would say def cube, since that's the name of my function, and say a, because I just want one value. I don't want two values in this case. I just want to print the cube of this number, and I would just say a multiplied by a multiplied by a. This is cube. So on calling the cube root of 3, it should print 27, and let's just try with a few more numbers. Okay. So what happens if we print a function call? So this is basically a function call. So what happens is, when I say cube, it refers to the function here. So this 25 gets passed to a. So a here stores the value of 25, and once a stores the value of 25, it just performs the operation of cubing up 25 and printing the output here. So to make that clear. Okay, so this is called a function call, and this is the function itself. So what happens if we print a function call? Let's try printing this thing. Let's see what happens. You can see that it prints none. The reason why it prints none is this function call does not return anything. So this, when we call this function, it just performs the statements under it, and that's it. The job of the function is done. So on printing the function call, it's going to print none because it does not, no value is being returned by the function. So, but what if I want to return like a value? Let's say I want to store whatever is in another variable called x. How would I do that? So a simple modification needs to be done. So we'll have the same program, and let's compute a cube, and let's just store it in a different variable. So if I want to return the value of a cube, all I need to do is use a statement called the return statement. So if I say return b, it will return the value of b computed back to the function call. So now let me try printing, let's say, cube of 3. Let's see what happens. You can see that it prints 27. So since the value b is returned back on printing this, it prints 27, which is the returned value of b. I can also store it in a different variable, say x. Let me just compute a different thing. So, and let me try printing x. You can see that it works. So on calling this function, what happens is this whole function is run and the value of b is returned. So you can basically think, instead of the place of cube of 3, you can just think it as it's just saying print b or print 27, because 27 is being returned. So once the whole function call is finished, 27 is returned, so you're essentially printing 27. And the same case here, if I call cube of 27, it computes the cube of 27 and it essentially returns 19683, which is then stored to x, and x is printed. So let me just illustrate another thing. So let's say I want to have a function which divides two numbers, and I want to calculate the quotient here, which would be a divided by b, and I want to return the quotient. So printing, say, divide 6, 2, and maybe I'll just do the same thing, 13, 2, and let's print x. Oh, you can see that the output is returned. So you can pass how many ever values that you want. You can pass in 2 and so on. So but you have to remember, if you have 2 values here, you have to pass in 2 values here. You can't just give one and expect it to automatically take the other thing, because b does not hold any value. Whatever value you pass here only gets stored in b. So a stores the value of 6 and b stores the value of 2. So you have to make sure that you give all the necessary values here that matches the number of variables that you've given here. And you can also have a function with no parameters. So let's say the purpose of my function is to just print hello. So all this function does is print hello. We don't need a parameter here because we just want to print hello. So calling the hello function would print hello. That's it. So you don't have to give any parameters as well or any variables here. You can just leave it blank. So to give a small recap, the syntax of a function is you type in the def statement first. You give a function a name, then you give the values that you want to be passed inside it in the form of variables. Then under it you type whatever commands that you want to get performed. To call a function, you type in the function name and you give it the values that you want to be passed here in the variables that you assigned or the parameters that you assigned. And functions also have a return statement which returns the desired value back. You can print the value or you can store the value however you want. Okay, so I'll give you guys a task now to solve. The task is, I want you to use a function. I want you to multiply n and n plus 1, where n starts from 1 and goes till 100. And I also want to want you to print the output for each computation. So to make it simple, all I want you to do is I want you to multiply 1 to 2 and print what is that, then 2 into 3, 3 into 4 till 99 into 100, and each time I want you to print the output. So, and all this multiplication has to be done inside a function. So this multiplication here should be done inside a function, and I want you to multiply from 1 till 100, which is n into n plus 1, and I want you to print the output for each computation. So your output would look like this: 2, 6, 12, and so on. So that's what I want you to do. I'll give you guys like few minutes to solve the task, then we'll go through how we'll be actually solving it. Okay, I think that should be enough time for you guys to solve it. So let's see how I would go about it. So simple thing, the function that we need is to multiply two numbers. So we just declare a function called mult which would multiply two numbers. So We declare two parameters a and b, and all we need to do is we just print a multiplied by b. That's for the function part of the program. So the next thing that we would need to do is we need to start from 1 and go through 100. So a simpler way would be to use a for loop, which will start from range 1 and go till 100, and we'll just call the function and say I comma I plus 1. So I would first take the value of 1, I plus 1 will be 2, and it will be 2, 3, 4, 5 and so on, and at the end we would get the I'm sorry. Yep, you can see that it starts from 2 and we get till 9,900. So we declared a function which multiplies two numbers, and we just call the function using different values by using a for loop which starts from 1 and goes till 100. That way making it much easier to perform this task. Okay, so next what we'll see is we've seen arguments here like a comma b and so on. We have something called default arguments. So a default argument is something whose values are specified in the function definition itself. So let's say a function called interest, which would calculate the interest. So I have the principal amount, and I have the time, and I have the rate. So what if I want to set the rate to 0.1 defaultly, and now I'll just perform the calculation, which is principal multiplied by time multiplied by rate, and I'll just divide by 0. Okay. So now let me just try calling this function with 10, 10, 10 and everything. Let's see what it means. It should print 10 because we're multiplying 10 3 times, which would give us 1000, and 1000 divided by 100 is 10. Okay. Let's try giving only 2 parameters and not 3. What will happen? So what happens here is 10 gets stored in principal, 10 gets stored in time, and since we haven't given any value for rate, and rate has already been defaultly assigned to 0.1, it takes the value of 0.1. So this is called a default parameter. So what happens is we're assigning the value of rate to 0.1 defaultly. So even if the user does not give any value for rate, it takes the value stored here. But if the user gives any value, this value is overwritten and this value gets stored in rate. One thing you can notice, you can't just say 10 here. It would show you an error because time has not been assigned anything defaultly. So 10 gets assigned to principal, but there's no value which gets assigned to time. So it would give you an error. So you need to make sure that every value you give either you store it in a variable or has been defaultly assigned so that you don't have to give a value. And another thing that you should note is I can't do this, which is declaring a default parameter before the actual parameters. So these are called actual parameters or the required parameters, and this is called a default parameter because we're defaultly assigning a value to it. So now if I just copy the code. And let me just try calling it. So this would return an error because it says a non-default argument follows default argument. The reason is the default argument should always be the last one that is present. So it should not come in between or anything. A default argument should always be the last. So giving it before these parameters will show you an error. So that's how Python works, and that's the principle behind it. So you all have to make sure that the rate is given or the default parameter is given before the actual parameters. Okay. So there's one more handy thing in Python which makes it much more easier. So let me just take the same function here. So it's not necessary that you have to give the parameters in the same order. So let's say I give parameters of 1030 and 0.2. In this case, 1000 gets assigned to principal, 30 gets assigned to time, and 0.2 gets assigned to rate. So the first in this position will get assigned to the first in here, and so on. But you don't have to necessarily give it in that order. So you can change the order, but the thing that you have to do is you have to say time is equal to 30, rate is equal to 0.2, and principal equals 1000. So it's the same thing here, except if I want to change the order, I have to give the variable and assign it here itself. So if I can't change the order here because it's been positionally defined. So everything in the first position will go to the first position here, second, third, and third. So if I want to modify the positions, all I have to do is I have to type the variable name, assign it to something, so that when I do this, what happens is time gets the value of 30, rate gets value of 0.2, and principal gets the value of 1000. Let's run it to see that if it's true. You can see that both the times the same value gets outputted, which proves that time stores value of 30, rate stores value of 0.2, and principal to 1000. So this is basically us using the argument's name to assign the parameters here in the call itself. So this can be given in any order you want. So changing the order, you need to use the variable name and assign it here so that you can give it in any order that you want. Okay, we did see how we can return values, but Python also supports returning multiple values. So let's say I have a function called squared, which takes in a, b, and c. So I want to return a multiplied by b, b multiplied by c, and c multiplied by a, basically multiplying each number by each other. So since Python supports multiple return values, all I need to do is say return a into b, and return b into c, and return a into c. So now let's try doing two things. The first thing, let's try printing this and see what happens. Let me just give 3, 4, 5. Cool. You can see that it returns as a tuple. So if you try to return multiple values from a function, it automatically stores each of these values in a tuple and gets returned as a tuple. So even if I try storing it in a variable, it would automatically get stored as a tuple. So let me try printing it. Oh my God. So you can see that it returns as a tuple. But if you want each of these to get stored in different variables, you have something called as unpacking a tuple, which you have learned in previous lectures. So to separate each of these values in different variables, all you need to do is declare 3 variables and say is equal to squared, and let me just call the same 3 values here and try to print x, y, and z. So in this case, what happens is all these values are returned as a tuple, but since we have unpacking of a tuple in Python, 12 gets stored to x, 20 gets stored to y, and 15 gets stored to z. So but you have to make sure that you give the same number of variables here, which equates to the same number of return values. So even if I miss one here, it's going to return an error because it says too many values to unpack expected to, because 3 values are here and we've only given 2. So that's why it says the error that there are too many values to unpack. So you have to make sure that you give the same number of variables that you want that has to be returned. So that is returning multiple values. So it returns as a tuple, and to unpack it you need to give the few equal number of variables so that you can unpack them. And we also saw that you can assign default parameters which won't change unless overwritten by the function call. So if the function call does not have a value pertaining to this default parameter, the default parameter's value stays as it is. And we also found that a default parameter has to always come after the normal parameters here. It can't come before or between. It should be the last one that's present. You can have n number of default parameters, but make sure all the default parameters are at the end of the arguments. And you can interchange the function call values that you pass in by typing in the variable name and equating to the value that you pass. And at the end we show about returning multiple values by a tuple and unpacking the tuple. So I'll give you guys another task to do. So I wanted to write a program with a function that receives two numbers as an input and generates 10 random integers from that range. So your output should be like this. You would need to ask for a start value, and you would need to ask for an end value, and 10 random integers in this range should be outputted. So maybe random integers like 32, 56, 9, 32 and so on. So I need 10 random integers from this range to be inputted. So, and this should be done via a function. So this is the task now. I'll give you guys like 2 to 3 minutes to solve. It's pretty simple task to solve. I think that should be enough time. Okay, so let's see how we would solve this task. So the first thing that we need to do is, since we need to generate random integers, we would need to import the random module. Then since we need to define a function that receives two numbers and inputs random integers, so let me just define a function called RunNum. It takes two values, and basically what it does is it returns a random number or a random integer in this case in that range. So the range would be a comma b. That's for the function definition. Then I would need two variables from the user. So it would be a start value and an end value. So once that is done, since I want to generate 10 random integers, I would do a for loop, making it much easier. So I'll just call the function repeatedly and say print RunNum x comma y. So I didn't ask you to receive two numbers 10 times. You just have to receive the two numbers once, and using that end and start value, print 10 or generate 10 random integers. So let's say I give start value of 10 and end value of 83. You should see that it prints 10 random integers using that. So to keep it in simple terms, we get two variables from the user, and we call a function called RunNum 10 times. So RunNum takes two values and returns a random integer between that range. Simple as it is. Okay. So let's see something called the scope of variables, and let's see what that is. So let's say a function called sum, which takes in two variables and just adds both of them. And what the sum thing does is it stores the addition in another variable called sum1, and then it prints sum1. So that's the function definition here. So I call sum here and I pass in 3, 2. So what would happen is sum1 would have 3 plus 2, which is 5, and it would print 5. So what happens if I try printing sum1 here? It shows an error called name sum1 is not defined. And you would have probably seen this error while you were programming. This error comes when a certain variable is not defined, or you haven't defined a certain variable. So the reason why this comes, even though we have declared a variable called sum1 here, is this variable can exist only within this, under this function. And if I try to access it outside the function, it won't, because this function only exists inside the function. Or to be specific, the scope of this function is inside, the scope of this variable is inside this function. Hence, it's called a local variable. The reason being, it has a local scope which is inside the function. So trying to access it outside would not be possible because it's a local variable. So what can I do if I want to access this variable outside? So what I would need to do is, maybe before that, let's see if the opposite works. So let's say I have a list called 243 here and a test here, and let's say I want to append 4 to this list and just print the list. So I'm just going to call test and print A here. So you can see that here, since the variable is declared outside the function, we could still access it inside the function. Whereas here, the variable which was declared inside the function could not be accessed outside. So this A here, since it's been declared outside, it can be accessed by anything that's in the code. This is in the outermost part of the code. So it could be accessed by any functions, if statements, or while loops. Whereas this, since it's declared inside a function, the scope of this is confined to this function and can't be accessed outside. So what if we want to have a variable like this which can be accessed outside as well? So that's when we have something called a global variable. So let's see how it works. So to declare a variable, a global, I have to give the keyword global and declare the variable first. Then I can use the variable here 1 2 3, and let's say I have a function and which, let's say I declare another A. I change the A's value to this and I append A to 5 and I print A here. I call the function and I print A. So what we have is, we have declared a variable global here, which means it can be accessed anywhere, and we have assigned that global A to 1 2 3. We have a function called check here, and we've also assigned a variable A here, which has been equated to 2 and 2 3 4, and we're appending this list with 5 and we're printing it here, and we're also printing it again here. So let's see what the output is to understand it better. You can see that it prints a surprisingly different output. So what happens here is, we have A here which contains 1 2 and 3, and we have another A here which is 2 3 and 4, but there's one problem here. Since this A and this A are completely different, the reason being, this is a global A and this is a local A. So since we are assigning A here, this A exists only within this. Whereas if I tried printing A here before, it would have again said the local variable A was referenced before the assignment. So even though this is a global variable A, we are not referring to as global A here. We're defining a new variable A which has 2 3 and 4, and we append 5 to it, and printing it results in printing 2 3 4 and 5. And when we try to print A outside this definition, what happens is it prints the global variable. So to maybe illustrate it much better, let's do it the opposite way and check. So let me declare a global A inside a loop, inside a function, and I say give it 1 2 and 3, and I append 4 to it, and this would result in the list having 1 2 3 and 4. I run this function and I try to access A outside. Let's see what happens. You can see that here, since I've declared a global A, and declaring it a global A basically means this variable here can be accessed outside itself. Previously we noticed that a variable declared inside cannot be accessed outside, it says it's not defined. But since we have declared A to be global, this a can be accessed inside the function and outside as well. But let's try changing the value of a to something else like 2, 3 and 4. Now let's try printing it. Now what happens is this no more refers to the global a. Since we have another a declared here, it's going to refer to this a here. The same thing is what happened here. So even though this is global, since I have an a declared here, printing the a would print this and not the global one, because I'm not accessing the global. Whereas in this case I have a global a and I'm using the global a to append. Therefore this gets printed. Whereas here it's not the global a that's being accessed. So this a is completely different from this, whereas this is a global variable and this is a local variable. That's the difference between both of them. So before we wrap up this week's lecture, since we're talking about functions, let's just look into a few built-in functions that Python has. So let's say I have a integer 1, 2, 3 and I want the binary equivalent of it. So Python has a built-in function called bin, which is short for binary. So using bin, a would return the binary of 1, 2, 3. It has a prefix of 0b to show that it's binary, and it returns the binary here, and this is a binary, it's a string. So to convert it into octadecimal, which is OCT, short for octadecimal, and octadecimal is prefixed by 0O. So binary is by base 2, it's zeros and ones, whereas octadecimal is base 8, which goes from 1 to 7, or 0 to 7, sorry. And we have hexadecimal here, which is 16. So it goes A, B, C, D and so on. It totally has 16 base numbers. So on printing hex, it starts with the prefix of 0x and then the hexadecimal equivalent of it. So the bin for binary, OCT for octadecimal, and hex for hexadecimal. These are a few built-in functions that Python has. And Python has also this interesting function, but maybe I would call it useless but it's kind of cool either way. So let's say I have a statement which says, or a string which says print hello world. I'll just give it in different quotes. Okay. So you can see that this is a Python command, but it's in a string format here. So if I try to print code 1, it would just say print hello world. So Python has this function called exe, execute. So on executing this, what would happen is this string would get converted to Python code and it would be run. You can see that it runs as hello world here. So this function basically what it does, it converts the string that you have into the script of Python and it runs. And in case we had certain errors, it's still going to show error. So maybe one reason I would probably find using it, but still I would not recommend using it, is maybe ask for an input from the user, say enter a Python command. This is clearly not secure, but maybe in some case you want to do is and try executing it. So as a user I can say so on executing this it would print the statement here. So on this note I end today's lecture, and I hope you guys have fun in solving the homework that is assigned to you. So I made sure in this week's homework you get extra practice of lists, for loops and so on, not just practice with this week's topic of functions. So in each week you will have extra sums based on the previous lecture so that you get practice on those concepts as well, and not only on those which the lecture is based on. And on that note I end today's lecture and see you guys next week.